Hello everyone, and this is Dumbass Academy, and today we will be figuring out how to calculate the centimeters per second of anime titties. Now what am I saying? Whenever you watch an anime, you obviously know that the titty physics are quite questionable. And today we are going to show how it is calculated. We are going to calculate how much centimeters each titty travels per second. And I'll tell you that it can happen in real life. So, for our equation, we can represent this with CPS. This is just going to be our centimeters per second. So, we can represent with this simple, and I mean really simple equation right here. And let me think. Okay, so so for our equation, we have our forces. Force 1 and force 2. Force 1 is the force with which the anime girl is walking forward. This can be, for example, 5 inches per second. Then we have our force 2, the force of which the body is trying to pull the titties back and prevent them from going into stratosphere. Let's say as 3 inches per second. Now, this only calculates the x velocity, which is just walking. So it's extremely useless. So, you are probably wondering, how can we fix this? Well, it's pretty simple. With some simple multiplication. I don't know, I'll try to draw a multiplication sign. Yeah, period, there we go. Actually, no, I'm going to do that. I'm gonna do period. Okay. Now we can represent that by the overall speed of the anime girl. This is usually equal to F1, and we can represent with S. And basically, this will calculate a bit of the y velocity. Now, if we do this right now, we plug in values. For example, force 1 is 5, F2 is 3, and S is 5. Well, then here's what we get. So we do 5 minus 3, and that's 2, times 5, that's 10. Now, 10 centimeters per second seems pretty fishy. It doesn't seem fast enough. So that means we know something is wrong with our equation. So we had the second part of our equation. It's pretty simple. So whenever you are walking, your legs are at a certain angle. When you are standing still, your legs are at a 180-degree angle. Now, whenever you move, your legs can be at like a 90 angle or maybe a negative 90 angle. And this, of course, affects your height because if you're just standing completely still with both legs straight, you're higher than if you are, for example, in the middle of a walk where your legs slightly crouching. If you know the animation walk cycle, you can see this clearly. So how can you represent this in our equation? It's simple. We use L1 and L2. Oh wait, I completely wrong. L1 plus L2. And that's our equation. We have F1 minus F2 times S plus... Oh wait, we have F1 minus F2 times S plus L1 plus L2. Now it is time for our equation. Let's say our force 1 is 4. That also includes for speed. So we'll just write this down as we go. Our force 2 is going to be 3, like in our little example. And now we can do 4. That's the first part of our equation. Now, of course, we already know that that's too tiny. So now we have 4 centimeters per second. Disgusting. So we're just going to put that in parentheses right here. And I'll put you guys in parentheses. So now we have to add it by L1. So let's say our first leg is at a negative 90-degree angle. So she is in the middle of a walk. Actually, no. Let's make it so that. Okay, let me think. What would be a great example? Okay, let's say our first leg is, for example. Okay, let me think. Let's say our leg 1 is behind. So that means it's going to be negative 90. It's negative 90-degree angle. We can add that by L2. So L2, for example, let's say that leg is completely straight. That is a 180. Now, we have to solve everything. This is extremely simple. All we have to do is add 4 plus 3. We can condense that down to 1 times a 4, which is... Well, that was the most pathetic 4 I've ever drawn. Which is obviously equal to 4. So we figure out the first side of the equation. Now you have to add this by negative 90. Now, if you know PEMDAS, addition always goes first. So we have to do, let me add that plus right there. And we have subtraction, so let me put parentheses right there, I got it. So first we're going to add negative 90, and, oh my god, okay, this is actually, okay, there we go. So negative 90 plus 80, so let me just write that equation in my calculator for a sec. And when we punch numbers, we get 90. So now it's just 4 plus 90. And that is equal to 94. CPS is equal to 94. And that, my friend, is how to calculate the velocity of anime titties. Now, do keep in mind that you will always have to do a frame analysis. Basically, what I mean is that this is not a constant equation. You can't just punch in the same values for each frame in the animation. That means this will never always be accurate, and it will only be an estimate. However, it's still good enough. So we can represent this 94. So we can represent this 94 as AES, average estimated seconds. So CPS. So in CPS, or in centimeters per second, it is equal to 94. So in centimeters per second is equal to 94. Okay. So oh my god, okay. So estimate seconds. So let's pretend that A doesn't exist. So estimated seconds. So 94 estimated seconds, right? And that is how we calculate that. You can use this for many other values, and I hope this dumbass accounting tutorial helped you. Anyways, that is it. I must go back to teach you my own class now.